Okay, hey everyone. Well, it was good to meet with many of you, and hopefully, we'll get everyone on board in the next session. But I want to go ahead and start posting videos for lesson 4.4. I'll probably do this in two, actually, probably three parts. And so this is 4.4a. I have attached along with this the notes. And the first thing I'd like you to do is make sure you can get a hold of those notes, whether you find them and make and print a copy, or I continue to recommend maybe you access those notes and you copy them by hand into your notes. I think that will actually help the learning process for you to do so. But I want to start with some problems where we're given an angle, and the angle is in standard position, and that means its initial side is along the positive x-axis, and its terminal side is somewhere else that we can look at in a graph. And we looked at such angles with a unit circle. We saw with a unit circle, all I have to do is find the x value, and that's the cosine of this angle. And I have to look for the y value to find the sine. And we learned how to kind of go through all of the 6 trigonometric ratios when we had information about the unit circle. Now we're going to look at some that just have specific points that may not be unit circle points, and we're going to be able to solve these actually by going back to our knowledge of right triangles in SOHCAHTOA. And ultimately, we're going to learn about something called reference angles. It's going to help us tremendously in this unit. So here's what I want us to do. I guess I want you looking at the notes. It says, I'm just reading along, for an angle whose terminal side passes through any point, xy, the trig values can easily be found by drawing out a right triangle and using ratios SOHCAHTOA. And it talks about the sine SIGN of the x and y values being significant, and the fact that whatever we come up with as a hypotenuse for our right triangle, we'll always count that as positive. Hopefully you'll understand where we're coming from on all of this. I'd say let's start with an example that's in the first quadrant. The first quadrant is simpler, and we'll get an idea of how to do this, and then we'll be able to do it in other quadrants as well. So this is a fairly simple warm-up that I think you probably should be able to do. Okay, I have an angle in standard position. I don't know what that angle is. I'm just going to call it theta. I see that it does terminate in the first quadrant, and I know that it passes through the point 4,6. I'm trying to learn to write a little larger on the board. I'm hoping that you can see that, but it passes through the point 4,6, and I'd like to know all 6 trig values for theta: sine, cosine, tangent. And please remember, you can't say, oh, look, the x value is 4. The cosine of this angle must be 4, because that only works if we have the point where it passes through the unit circle. And that's not the case here. We can't say, oh, y value is 6, so the sine is 6. But what we can do pretty easily is drop straight down here and create for ourselves a right triangle, right? Hopefully you can see, well, the distance from the origin to here is actually the same as the x value. That's 4. And the distance from the x-axis up to that point is really just the y value. That's 6. The only thing I don't know in this right triangle is the hypotenuse. And we can use the Pythagorean theorem to come up with the length of this piece of the hypotenuse. So c squared equals a squared plus b squared. C squared equals 16 plus 36. C squared equals 52. hope I did my math right. 36, 46, 52. That means C equals the square root of 52, which I can label up there. I need to make sure if I have a simplifiable square root that I do simplify it, because I think that the number 4 actually divides into 52. And so this could break down four times 13. And the reason I did that was I can pull out the 4 by taking the square root, and it becomes 2 root 13. Okay, we worked on that a lot at the beginning of the year. Sorry, you're going to have to be able to do that. But now I've got 3 sides of a right triangle. All of the trigonometric ratios should be nice and easy. Sine theta. Here's theta. I want sine, which is opposite over hypotenuse. 6 over 2 root 13. Which I know I can't keep like that, but that's okay. We can times by root 13 over root 13. That becomes 6 root 13 over. Square root of 13 times the square root of 13 is 20, is 13 times 2 is 26. And that can also be reduced. And hopefully this doesn't get too messy, but if I divide both of these by 2, I have 3 root 13 over 13. Okay. That's the sine of my angle theta. Cosine theta. By the way, y'all should be playing along. If you have a piece of paper, you can write this out, and it's going to help you to engage and try to do this yourself. Remind yourself, what is the cosine of an angle? It's the adjacent over hypotenuse. 4 over 2 root 13. And so again, we do root 13 times root 13. And I get, tell you what, I'm going to make it a little easier on myself by reducing right here at the beginning. This and this becomes 2 over 1. You guys good with that? Draw it out on paper. I'm sure you'll come up with that. 2 root 13 over 13. So I have 3 root 13 over 13 for the sine. I have 2 root 13 over 13 for the cosine. And remember that the tangent is sine divided by cosine. This was my sine. This is my cosine. And to divide them, I flip and multiply. So that becomes 13 over 2 root 13. And a bunch of things are going to cancel out. Hopefully you see my 13s cancel out, my root 13s cancel out, and the I'm not going to rewrite it, equals 3 over 2. All right. That might seem really messy, but it actually goes pretty quick if we can remember SOHCAHTOA. Hopefully you have that written down and committed to memory. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. I guess my life would have gone a whole lot quicker if I remember that too, because that's just 6/4 reduces to 3/2. Well, there's a good reminder that tangent is also sine over cosine, because I took the really long path to get to the same answer. You guys will be smarter than me there. Just remember that tangent is opposite over adjacent. It also means the next three are a whole lot simpler. Who remembers what the flip or the inverse of sine is? It's cosecant. So cosecant theta, and probably right at the beginning, you see where we first wrote sine down, that's where we should flip it. Or I can just look at my original triangle and remember it's hypotenuse over opposite. So 2 root 13 over 6. Those reduce to 1/3. I have root 13 over 3. Okay. Secant, hypotenuse over adjacent, 2 root 13 over 4. This reduces to 1/2. So I have root 13 over 2. And cotangent is the flip of tangent, or adjacent over opposite, which would just be 2/3. All right, that's how we're going to deal with it when I have a point that was given to me that was not on the unit circle. We're just going to create ourselves a right triangle. You go practice them. It's not going to end up being as difficult as it might seem or might look. You just have to remember some of the rules with radicals and with the Pythagorean theorem. SOHCAHTOA, it kind of brings everything together. Now, here's the important thing for when life gets a little more interesting. Please note that this angle terminates or ends in the first quadrant. Now, again, this point is not on the unit circle, but somewhere along here, there's a point that would be on the unit circle. And I know at that point, the x value would be my cosine, the y value would be my sine. And I'm pretty sure in the first quadrant, both the cosine and the sine are positive values. The x and the y are both positive here in the first quadrant, which means pretty much everything here is going to be positive. That's going to change when I have angles that terminate second, third, and fourth quadrant. But what I want you to remember is the idea that at least on the unit circle, the x value indicates cosine, the y value indicates sine. So you can look at any point anywhere else and say, well, okay, the x value for this point, is it positive or negative? The x value for this point, is it positive or negative? Because if the x value is positive, cosine is going to be positive, and also its flip, secant, is going to be positive. If the y value is positive, then you know that sine is going to be positive, and its flip, cosecant, is going to be positive. Tangent's interesting because tangent will be positive when x and y are both positive, or when x and y are both negative. They'll cancel each other out. Now, there's a way actually going to sneak you to the end of your notes that can help us a whole lot. So let me erase this. Just look at our graph for a second. What a mess, what a mess. Tried to leave up our x and y axes, and I'll come back to this and remind you, but up here, the x value in the first quadrant is always positive. The y value is always positive. That means every trig function on an angle that ends here is going to be positive, all of them. And so I'm just going to put a letter A there to remind me if there's any angle that terminates here in the first quadrant, everything is going to be positive. If I had an angle that terminated over here, well, this is kind of anything up over here. This kind of has a negative x value. And that means that cosine is going to be negative. Also, its flip. Sine is the y value. Well, that's up. That's going to be positive. So sine and cosecant are going to be positive. And tangent is sine over cosine. That's actually going to be negative. All right. I can go back and show you that, but I'm just trying to show you the quick shortcut to remember. I'm going to put a letter S because sine is the only thing positive here. And the flip of sine, which is cosecant. All right. Down here, the x values and the y values are both negative, which means my sines and cosines and their flips are all going to be negative, but tangents actually turn out to be positive, tangent and cotangent. So I'm going to put a T there. And here in the last quadrant, it turns out only cosine and its flip are positive. Everything else is negative. And so we have these letters A, S, T, C going quadrant 1, 2, 3, 4. This describes you guys. You are a smart trigonometry class. A smart trig class. If you can remember that goofy little acronym, then you can just kind of apply the correct signs, S-I-G-N, to any given angle. Let me show you a case in point. We'll get to practice what we just did, and we will get to deal with this as well. I'd like you guys to play along. What I want you to do is draw a graph, X and Y axes, and we're going to have an angle in standard position. So its initial side is there, and it terminates over here. This is our angle. It's an unknown angle. We can call it theta. We can call it T. And here's a point that my terminal side passes through. Taking this one from the book, it is -3, -5. Can you guys see that okay? It's a little sloppy, but hopefully it's large enough for you all to see. And the question is, what are all 6 trig ratios? Call this angle T. And the key to this, and this is going to set up what we're going to learn about called reference angles, is actually I have an obtuse angle here. It's kind of hard to make a right triangle, but we can get away. We're allowed to actually make a right triangle with the negative x-axis over here. And instead of this whole big angle T, we're allowed to kind of use this angle here as a reference. It's ultimately what we're going to call a reference angle in the next video. So here's what I want you to look at in this triangle that I created. Okay, the distance from here to here, this side of the triangle, is just my x distance, which is the length is 3, but it's -3 because it's to the left. And I'm going to write -3 because that's going to help me remember that the x value is a negative value. That means I know that my cosine is going to be negative. It's not necessarily negative 3, but it's going to be negative. This side of the triangle is just the y value. It's down 5. It's negative 5. And if I wanted to do SOHCAHTOA with this triangle to get some important information, I have to find the hypotenuse. And so let's do c squared equals a squared plus b squared. Now, doesn't matter that it's negative 3 because when I square it, it just becomes 9. This is negative 5. When I square it, it becomes 25. And so c squared equals 9 plus 25 is 34. C equals square root 34. And you can look to see if that is simplifiable, but I don't think it is. I know that 4 doesn't divide into that, 9 doesn't divide into that, 16 doesn't divide into that. So we're just going to call this square root 34. I can't pull out any simpler perfect squares. So please look at these values. And now let's just SOHCAHTOA this. To pull out all of our 6 ratios, right? Remember, here's the angle that we're using as a guideline right there. And so I would do, to find the sine, I would do the opposite over the hypotenuse. Negative 5 over root 34 is the sine. You guys know I've got to clean that up and fix that a little bit. Square root 34 over square root 34, and I get negative 5 square root 34 over 34, right? And I want you to notice again that the sine came out to be a negative value. I know if I were using a unit circle and sine represented the y value, well, y here at this point on a graph is definitely negative. So that should make sense. I should have anticipated, even if I didn't write in these negatives, I should have known to stick a negative there because it ends or terminates in the third quadrant, right? Cosine, adjacent over hypotenuse, negative 3 over root 34. Clean it up by rationalizing the denominator, negative 3 root 34 over 34. Again, in this quadrant, the x value is positive, and so I fully expected the cosine, the x value is negative, sorry. I fully expected the cosine to also be negative. But I notice when I do tangent, that's opposite over adjacent. It's a negative over a negative. They cancel each other out. So the tangent simply going to be a positive 5/3. Let me remind you what I wrote before. A smart trig class, ASTC. Here I'm expecting tangents to be positive. And again, that's what we got. Let's go to cosecant. Let's go right here, right at the beginning. Flip that, root 34 over negative 5. I can put the negative out in front if I want. And I don't need to clean that up. I can't reduce it. I'm really happy with that. Okay. Secant is the flip of cosine. Negative root 34 over 3, and cotangent is the flip of tangent. That's just going to be 3/5. And again, that's the only one that's going to be positive because it's the flip of a positive value. Both of these were flips of negative values, and they will also be negative. So I'd really like you to practice a couple of these. That'll be part of the homework and see how you guys do. One other thing before this video ends. I know the video is getting a little long, but I want to show you what we call quadrantal angles, and they're actually really easy. We're going to go back to unit circles to deal with quadrantal angles. A quadrantal angle is any angle that is in standard position. It starts here along the positive x-axis, and it ends actually on an axis, positive y or negative x or negative y. And so let's do this angle here, which we would call 180 degrees, or in radians we might call that pi. And I want to know all of the trig functions of 180 degrees, or pi radians. What I would suggest is let's think about, well, where would that pass through if I had a unit circle? If this length was 1, what would this point here be? What would its x value be? It would be -1. What would its y value be? It would be 0. And that's all the information that we need for a quadrantal angle to do all 6 trig functions. Remember, I'm back to a unit circle. So the sine is just the y value, is it not? It is. And that's just 0. The cosine of this angle is just the x value, -1. The tangent is sine over cosine, or y over x, 0 over -1, that's 0. I can have a fraction with 0 at the top. It's just equal to 0. All right, now they get a little tricky. Cosecant is 1 over sine, or 1 over 0. That I'm not allowed to have. And so we're going to say this is undefined. Can't be. All right. Secant is up. No, I got it right. All right. Secant is going to be the flip of cosine, or 1 over -1. And hopefully you see that is just -1. Cotangent is the flip of tangent. So that would be -1 over 0. Also undefined. For these angles that are called quadrantal angles, and in your note it says they're angles that terminate on the x or y axis. And so I gave you a few examples, but there could be an infinite number of examples. We'll go back to the unit circle and we'll use some of that information, and hopefully those will be nice and easy. So stop this video. Sorry it went a little long, but hopefully the subsequent videos will go quicker. I want you to practice some of these problems, and we'll come back and continue with the other videos.